Hello everyone, and this is lesson 5 of the Intro to Houdini series. So what we're going to do in this lesson is something fairly simple. We're going to make a spiral staircase, and in order to do that, or through the process of doing that, we'll take a look at a couple of things, which is how to use a little bit of math in Houdini and how to use the copy tool within Houdini. Okay, so let's get started. Okay, so I'm just going to take a piece of geometry and let's jump in. So the first thing we want to do is I want to create a box which will form my staircase. Okay, so I'm going to take a box. Now what I want to do with the box is I want this box to be like, the box is currently like midway, right? It forms like, half up, half down. What we would like is for this box to be on top of the grid. Okay, so the way that works is if you do some fairly simple math, which is if we move this, if we take the box and we move it up by half the height, okay, like if we take a look at this box and this is my grid, okay, or actually somewhere there. So it's half up and half down. Okay, and let's say this is a total height of 1. So if we move it up by 0.5, then the box will be, on top of the grid. And if you do it mathematically, so if we say the height of the box divided by 2, okay, so which is, you're doing like 1 divided by 2, which is 0.5. So if we move up by that much, then the box will always be on top of the grid. And so the nice thing about that is that if this height becomes 2, then the formula sort of still works. Okay, so because it's just a mathematical formula, even if the height keeps changing, this will keep updating and the box will always be on top of the grid. So the way it works is, we had seen how to do basic channel referencing the last time when we made the chair. So we're just going to carry that forward. So what we'll do is we'll take the Y size. Okay, we'll right click copy parameter and paste it in the center. Okay, in Y axis. So right click and paste relative reference. So what it is doing right now is it is moving it up by 1. Okay, so whatever is the size here is whatever is the value by which it is moving it. If you don't want to see the expression and you want to see the value the expression is generating, just click on the name of that parameter and it will sort of toggle between the name and the value. Okay, so what we want is we wanted to move by half the height. So what you do is you just type divided by 2 and there you go. So now the nice thing is, even if you move, as you keep adjusting the heights, you'll see like it keeps remaining stuck to the base. Okay. Like if you see the value here, you'll see as it keeps changing, you see that value change automatically. Okay. And that is exactly what we want. Okay. So anytime you want to do something like this is a fairly straightforward formula to do it. So the nice thing I like about like when I was using Max, and the problem with Max was that writing expressions is not exactly very simple, right? Like you have to right click, you have to assign a controller, and then you have to go into that controller and type expressions over there. This is fairly simple, right? You just sort of click within whatever parameter and just start typing, and it's fairly straightforward. So it makes it easier to sort of write expressions. Okay, so this is step 1. What I also want is I also wanted to move sideways in X, because what we want is we want like if this is my my grid, then the box should be like here. Okay, like this is where the box should be, right? Like it shouldn't be like in the middle, because we want to eventually like build a spiral staircase, so we want to rotate it from this point. Okay, so we want everything to be pushed like to one side of the grid. So we do the same thing. So we want to move it sideways in X as well. So right click, copy the X size and paste it in the center, and again divided by 2. So again, so if I adjust the X size, you'll see that it sort of adjusts automatically. And then we can just we can adjust the size of it. So I'll push it out a little and squeeze it. Okay. You can do this here, or you can also take like a transform node like we had taken the last time, and you can do the sizing here, like, just press E and then, the same thing. Okay. So the nice thing about doing it here is that the actual box size is still 1 and 1. So if you want to branch this out somewhere else and modify it into, like maybe I want another box like this, but in different sizes. So then it's still possible to do that. Okay. So you have like two boxes because the base box is 1 by 1. So we don't have to, if we change it here itself, then the transform will also get a squashed box. Look, we don't really want that. So let's just call this as step size. Okay, so this is effectively what I want. Okay, to begin with. Now we're going to use the copy node to make copies of this. So let's just take a look at the copy node first of all. Okay, so I'm just going to take a simple sphere. This is just like an example to show you what the copy node can do. I'll make it slightly smaller. Now, if you type copy, there are 3 copy nodes. Like forget the rest 3 here, like forget attribute copy and group copy and this stuff. But what you get are 3 copy nodes. And so the copy node at a basic level is fairly similar to the array tool within Max, or you have the cloner in Cinema 4D. Okay, so it's kind of similar to that. It has a ton of functionality which is not obvious when you just just use the node, but it can do like way too many things. But we're going to use it at a fairly basic level in this one. Okay, so if you type copy, you get 3 nodes. Okay, so you have copy and transform, you have copy stamp, and you have copy to points. Okay, earlier it used to just be copy stamp. Okay, like if you look at Houdini 15, then you will just have, if you type copy, you'll just get something called copy, okay, which contained these 2 things within it. Now they've separated it out to copy and transform and copy to points. So the point being, maybe this is sort of less memory consumption. Most of the times you end up using like copy to points. But when you want to do the really complicated stuff, you have to go back to copy stamp. Like that's the big one that contains everything. So I'll use copy stamp because for today's purposes, we need copy stamp. Okay, so we're just going to take copy stamp. Now it has 2 inputs. The left input is always the main one wherein the object goes. The second input is if you want to, like within the cloner, you have an option of copy on an object. So the object that you want to copy this onto is what comes into the right input. Right now we don't want to do that. So we're just going to just use the sphere. And so once you've done that, it's fairly simple. Like I can just drag this out and then you define number of copies. Okay, like fairly straightforward. Okay, so you have like, okay, hold on. Let me just change this to polygon and less number of faces. Okay, so you can do stuff like I can rotate it around. So each one rotates a bit. You can scale it down. So each one scales a little bit. You can, so it's fairly simple. It's nothing, overly complicated. Okay, you can also do a little bit of pivot translations, so if I want to, adjust the pivot. So there you go. See, so you can do stuff like that. Okay, if I just move it a little closer and then I can increase number of copies. So yeah, so you can do, you can do a fair bit of stuff with this. Like whatever you can do with MoGraph in Cinema 4D, you can do all of that with the copy node. If you want, like once you're done with this series, you can look at the MoGraph series that I have for Houdini. That will give you an idea of everything that you can do with this. Okay, so this is the basic copy node that we want. Okay, so what we're going to do is I want to copy this as like a spiral staircase. Okay, so we're just going to take a copy and we'll say copy stamp. And I can just, what I can do is fairly simple. I'm going to lift this up. Let's create about 3 copies and then we're going to rotate it. And then as we make copies, you'll see that, so move it up in y-axis and rotate it in the y-axis. Okay, and that gives you, like how much you want. Now within this, we can do a little bit of math, like if you want to do that, which is, let's say I always want this to fit, let me make this 0. So let's say what I want to do is I always want it to fit within a circle. So this is where you can use a few of the inbuilt variables that that Houdini has. Like if you click on help of any particular object or any particular node, then if you come down, you'll have something called locals, and locals gives you like copy specific variables. So these variables can be used within this particular node. They're specific to this node. So the way they are done is you type a dollar and then the name of that particular variable in capitals. Okay. So if you want to use cy, then it is $cy. If you want to use ncy, it is $ncy. Okay. So what this is essentially is cy is the copy number and ncy is the total number of copies. So to sort of give you an example is, okay, this should be interesting. So if I say that each copy should rotate based on that copy number. So copy number 0 will rotate 0 degrees, copy number 1 will rotate 1 degree, and copy number 2 will rotate 2 degrees, sort of like that. Or let's say we wanted to move it up by that value. Okay, so I'm going to press 0 here and just do okay, so the way it has to work is you have to turn off transform cumulative, otherwise it doesn't work. So just turn this off. So do $cy and you'll see something very interesting. So each copy number, what you're doing is each copy number is basically moving up based on the number of that particular copy. So copy number 13 is at a height of 13. Copy number 12 is at a height of 12, you know, basically like that. It starts from 0. So copy number 0 is at 0. Okay, like if I delete this, okay, and we do 0 here, and if I do $cy at this point, then you'll see the same thing happen. Okay, see. So you're getting like, it's like 1, 2, 3, 4, 5, 6. So it's very small values. But if I say multiply by 5, so each one is taking its particular value and multiplying it by 5. Now what we want to do here is we want it to always fit within a circle. Okay, so the way that works is, this is actually a pretty old tutorial. I'm just sort of recreating it because it helps go through a few topics. So the way it works is you say 360 degrees, which is what will form your circle, divided by the total number of copies. So what that will do is it will always take the total number of copies. Okay, so let's say we have 10 copies. And so what you're doing is you're saying 360 degrees divided by 10. So what that means is that each copy will rotate by 36 degrees. So, or if you have like 20 copies, then you'll say 360 degrees divided by 20. Okay, and so you are now rotating each one by 18. So that's essentially, so no matter how many number of copies you have, it will always divide that by 360 and give you the exact number of degrees you want to rotate it by. So you don't need to calculate, like that's the nice thing about it. So make sure you turn on transform cumulative again and you just do like 360 divided by $ncy. And there you go. So now here's the cool part, right? So if it's 2, it's like, you know, 0 and 180. If it's 3, then it's that much. And then if it's 4, it's 90 degrees. Okay. So no matter how many copies we have, it will always fit within a circle. If you wanted to fit within 180, you make this 180. Okay. See, so it will always fit within 180. So if you want a staircase that is only going like halfway, then you can do that. So we'll keep it to 360. And then let's say that it should, so that's like step 1 for the staircase. And then let's say what we want to do is we wanted to move maybe like double the height of my step. Okay. So one step and the second, there should be like, you know, a little bit of gap in the middle. So what I can do is I can come to step size. This is the y-axis height. So I can right click copy parameter, come in here, do paste relative reference, and let's do, so right now each step will be like sticking to the next step. See, so if I have like 100 of these, see, it's fitting within the circle always. Okay, so it will form exactly a circle and each one is sort of sticking to each other. So if I come here and I adjust the thickness of it, you'll see like it automatically adjusts. Okay. But what I would like is maybe a little bit of a gap. Okay, let's keep this to about 30 and you can take this and do multiply by 2. See, so you're getting like a gap of 2 between each one. So if we want, like as I said, like if this should be like a halfway thing, we can make it 180 degrees. So there you go. So your spiral staircase, goes from like here to there. And if we have say 60 copies, then see. So as you adjust, you can see like the height also keeps changing based on that. Sorry, I forgot the, yeah. Okay, so this is essentially it. Okay, as far as making like a basic spiral staircase. Now I want to add like one final thing into this. Okay, which is, okay, so the final thing I want to add into this would be that let's say there is a column in the middle. So what I want to do is, not only do I want to generate a column, I would like to push this out to whatever is the radius of that column. So let's say we take a simple line tool and I'll just give it some height. Okay, and I'm going to take a polywire. A polywire gives polygons thickness. Like if you have a line, then you can use a polywire and give it some thickness. And we'll also give it some division. So let's make it about 40 sides. So our radius is 0.6. So what I can do is, after the step size, I can take another transform and say I want to push this out by 0.6. So it's sticking to the edge of this staircase. So what I do is I take the radius, I'll do a copy, come in here, come to x-axis, okay, and paste relative reference. See, okay, and then if we merge these two together, you'll see this. So the nice thing here now is if I adjust this, if I adjust the thickness of this, you'll see that the steps keep sort of moving in and out, and my number of copies sort of, adjust based on this. And we can probably adjust it a little bit more. Like I can take the X size and sort of push it in a little bit. Yeah, there you go. See, so you can sort of adjust this thing going in and out. So the point being, like a little bit of math goes a fairly long way. Like that's the whole idea behind this. This, like as a tutorial, it might be fairly simple, but because the way we are connecting everything using math, it allows you to build a more controllable structure. Now you can do more things, like maybe we can figure out a math to have this line connected to the step. Okay, so you could probably do that. So essentially as we lower the height of the line, the overall staircase also adjusts. So you can do something like that. So yeah, you can do things like that as well if you want to. Like maybe we can try that. Like let's try something. Like let's take the length of the line. We'll do copy parameter. I'll come to copy and I'll paste it here. We'll do paste relative reference. Let's try something. Let's do divided by $NCY. Yeah, okay. So what we're doing is, you can see now, of course, now the problem is that the gap goes away. Like that gap is not going to work. Okay, but as you adjust the height of this, the staircase sort of adjusts. So you can do more stuff. Like if you want to, I don't want to go too complicated because it would require more calculations and more math to make this thing work continuously. But you can do a fair few things. Like we've managed to control this, but you can also say like, okay, as the line length is being lowered, the number of steps keep lowering. So you can do that. Okay, so as a final thing, let's say if we do want to, if you're completing the staircase. So let's say if we do want to have a connection where we can say that the height of the central column controls the number of steps. Okay. So again, it's not going to be very complicated. What we can do is we can just say for whatever is the length of the line, we should have 10 times the amount of steps. So when the height of the line is 1, we should have 10 steps. When it is 2, we should have 20 steps. Like that. Okay. So what we can do is let's keep this to a height of 4, and we can just come in here and we can do copy parameter, come to number of copies, we'll do paste relative reference and multiply it by 10. Okay. And so what that is going to do is, as you increase this, you'll now notice that, see, as I lower it, you'll see like the steps keep lowering. Okay. And as I keep increasing it, the steps keep increasing. And it always fits within 360. So that's the nice thing. And there you go. So that gives you, like, if you want, like, let's do one thing. Let's come to copy and make it like 720. So you'll get more. You could figure out a way to modify this as well. You know, like we could probably say, like, we can control everything coming in from the line. You know, like, let's say, like whatever is the length of the line, multiply that by 360. So each height step will give you a full 360. Or, you know, multiply that by 180. So when it's a height of 2, you'll get a full circle. When it's a height of 4, you'll get 2 circles. Yeah, you can do stuff like that. So as I said, so it's just a question of figuring out the math. Most of the times it's not going to be very complicated, but you just have to figure out how to make it work. Okay, so like if I come in here and I can, okay, like let's say I can just do this here itself. So I'll do a Control C and we'll do Control V. So this is going to be a bigger thing now, and I'll multiply it by 180. Okay, no, 180 is too much. Let's multiply it by 90. Yeah. So what is happening now is, for a height of 1, okay, we're only going to get like 90 degrees. See, and as the height keeps increasing, it also keeps turning around it. Okay. So now what you have is a fully controllable staircase. I'm hoping this is not very complicated. Okay, like here's the thing, right? Like if you look at it, it looks complicated. Okay, but we're running everything through the line distance. Okay, like whatever is the distance, like the length of the line, everything is being run through that. So the length of the line multiplied by 10 is the number of steps. The length of the line divided by the number of copies is the distance between the steps. The length of the line multiplied by 90, okay, divided by number of copies, is the rotation for each step. So yeah, it just, once you figure out the math behind it, it's not very complicated to try and make those connections. Okay, so as I said, like on the outside, the copy node looks very simple, but you can do a lot of stuff with it. Okay, so I am seriously hoping this lesson was clear. Okay, and if it isn't, well, you can write me an email as usual. Okay, so in the next lesson, we are going to continue with the staircase, and I'm going to add a few details onto the staircase so that it gives you an idea of how to make it into a more complete system if you want to. Like what we don't have right now are the railings on the side. So in the next lesson, we're going to see how to add, railings and like a guardrail and, stuff like that on the staircase. Okay, so as usual, I'm hoping this is clear. If you have any questions regarding this lesson, I'm sorry for the delay in the middle, but I had a cough, so I couldn't really record anything. So yeah, if you have any questions regarding this or any of the other lessons, then you can write me an email, or you can ask me a question on Twitter or Vimeo, or whatever you feel like. And as I said, in the next lesson, we will continue with this and see how to add more details to the staircase.